AWS Database Service provide fully managed, scalable, and secure databases in the cloud, allow the business to store, process, and analyze their data easily and efficiently. With AWS Database Service, users can choose from a variety of databases, including relational, non-relational, and in-memory databases, and pay only for what they use. AWS Database Services are fully managed, taking care of tasks such as backup, software patching, and hardware provisioning, enabling users to focus on their applications and data. AWS also provides a range of tools for monitoring and optimizing the database performance, ensure that users can deliver high quality, reliable services to their customers. So first, let's understand the difference between data, database, storage, and database engine. Data refers to the information. This can include text, numbers, images, and other types of data. Data can be organized into tables, with each table containing rows and columns. Data stored in the database. A database is a collection of data that is stored and managed by a database management system. A database can be a simple collection of data, such as spreadsheet, or a complex system with multiple tables, views, and relationships. Database is used to store, organize, and retrieve the data as needed. Storage refers to the physical or virtual location where the data is stored. In the context of database, storage can refer to the hard drive or solid state drive where the database files are stored, or it can refer to a cloud-based storage solutions like Amazon S3 that can be used to store data in the database. Data storage solutions are usually optimized for storing large amount of data in a highly available, durable, and scalable way, so that data is always available when needed, and the database can be scaled to handle increased traffic. A database engine, also known as storage engine, it is a component of a database management system that is responsible for managing the storage and retrieval of data. The database engine is responsible for managing the physical storage of data on disk and in memory, as well as executing the SQL queries and the transactions. A query language is a programming language used to communicate with a database. SQL, or structured query language, is a common query language used in a relational databases. But other databases like MongoDB, Cassandra, and Redis have their own query languages. These languages are used to insert, update, query, and delete the data in the database, as well as to create and modify the structure of database. In most RDBMS, SQL is used as the primary language to interact with the database engine. SQL commands are used to create, modify, and query the data stored in the database. And the database engine is responsible for interpreting those commands and managing the underlying data storage. In simple terms, you can think of a database as a container that holds the organized data, storage as the physical space where the database is stored, and a database engine as a software that manages the database and provide the tools for interacting with the data. Together, these components work to store, manage, and access the data in a structured and efficient way. AWS offers a wide range of database services, each designed to support different types of workload and use cases. Here are the primary database types available on the AWS. Relational databases. Relational databases are structured databases that store data in tables with predefined relationship between them. AWS offers several relational database services, including Amazon RDS, Amazon Aurora, Amazon Redshift. Non-relational databases. Non-relational databases, also known as NoSQL databases, are non-tabular databases that store data in flexible format. AWS offers several non-relational database services, including Amazon DynamoDB and Amazon DocumentDB. In-memory databases. In-memory databases are databases that store data in RAM instead of a disk, resulting in much faster data retrieval times. AWS offers Amazon Elasticache, or in-memory cache caching service that support the popular open source caching engines such as Redis and Memcache. Graph databases. Graph databases are designed to store and manage the relationship between data points, making them ideal for use cases such as social networks, recommendation engines, and fraud detection. AWS offers Amazon Neptune, a fully managed graph database service that enable users to build and run highly scalable graph applications. Overall, AWS provides a range of database services that cater to diverse business needs, enabling business to choose the right database service for their specific use case. Let's talk about the AWS Relational Database Service, or RDS, first. RDS leverages the platform as a service approach to run the database. It is important to note that RDS is a fully managed service, and it does handle core things like provisioning and patching, backup, and recovery of your database. Now, one of the great thing about RDS is that it does support deployments across multiple availability zone, and it also support read replicas for some of the platforms. That means you can actually scale out your database. This can help you scale more efficiently within the applications that are leveraging this database. Now, it is important to note that when you launch an RDS instance, it does launch into a VPC or a virtual private cloud. Now we talked previously about EBS and different volume types. And here within RDS, we have two different volume types that are available to us. First of all, we have general purpose SSD, and then we have provisional IOPS SSD drive. AWS offers a variety of relational database services, including Amazon RDS, a managed relational database service that makes it easy to set up, operate, and scale a relational database in the cloud. It supports popular database engines like MySQL, PostgreSQL, MariaDB, Oracle, and Microsoft SQL Server. Amazon Aurora, a fully managed MySQL and PostgreSQL compatible relational database service that deliver high performance and availability. DynamoDB, a fully managed NoSQL database service that supports key value and document data structure. Redshift, a fully managed data warehouse service that enable the fast querying and analysis of data using SQL and your existing business intelligence tools. Elasticache. Elasticache is a fully managed in-memory caching service that provide high performance, scalable, and secure caching solution for web applications. It supports two popular open source in-memory caching engines like Redis and Memcache and allow the users to create and manage the cache clusters easily in the cloud. Data migration service, a service that makes it easy to migrate your on-prem database to the cloud. Now let's talk about the different platforms that are supported within Amazon RDS. A database platform refers to the underlying software and operating system that a database management system runs on. Amazon RDS supports several platform or operating system for running the relational database, including MySQL, an open source relational database management system that runs on a various operating systems including Linux and Windows. PostgreSQL, a powerful open source object relational database system that runs on various operating systems including Linux and Windows. MariaDB, a community developed fork of MySQL. It is fully compatible with MySQL and it can be used as a drop-in replacement for it. SQL Server, a Microsoft Windows based operating system for running the SQL Server databases. Aurora, AWS own relational database engine that is fully compatible with both MySQL and PostgreSQL. Microsoft Windows, a Windows operating system for running the Microsoft SQL Server databases. By choosing one of these platforms, user can easily run their preferred relational database on Amazon RDS and take advantage of the service's managed capabilities. Now, you might be wondering, if you have a database that's running within your own data center and you want to move that database to cloud, how will you do that? AWS Data Migration Service is a fully managed service provided by AWS that makes it easy to migrate the database from one environment to another. DMS supports a wide variety of database platforms such as Oracle, SQL Server, MySQL, MariaDB, and MongoDB as a source and target. Data migration service enable you to move data into AWS from existing database and support both one-time and continual migration of data. DMS support many popular commercial and open source databases. You only need to pay for the compute leveraged in the migration process. DMS can be used for a variety of migration scenarios, including migrating a database from on-prem to the cloud, or migrating a database from one cloud provider to another, migrating a database from one region to another, or upgrading a database to a new version, creating a replica of a database for testing or disaster recovery process. DMS support to migrate the data between different versions, engine types, or platform. DMS use a variety of techniques to perform migrations such as full load, change data capture, and replication to ensure data consistency and minimal downtime. DMS also provides additional features such as ongoing replication and data validation to help you manage and monitor your migration. It also provides an option to use the AWS schema conversion tool to automate the conversion of database object and data type to the target database. Next, let's talk about Amazon DynamoDB. DynamoDB is a NoSQL database service that provides a flexible data models, automatic scaling, and high availability with built-in tolerance. It can handle large amount of structured and unstructured data, making it suitable for a wide range of use cases. DynamoDB is a fully managed database service, which means that AWS takes care of underlying infrastructure and database management tasks such as patching, scaling, and backups. Amazon DynamoDB is a fully managed NoSQL database service provided by AWS. It is designed to handle large amount of data with high performance and low latency. DynamoDB is a key value and document database, which means that data is stored in the form of key value pair, with each key representing a unique identifier for an item of data. The value can be of any type of data, such as string, number, or JSON document. DynamoDB provides the ability to store, retrieve, and query large amount of data with low latency. DynamoDB automatically scales the table up and down based on the volumes of requests and automatically distribute the data across multiple servers to ensure that data is always available when needed. DynamoDB offers in-memory cache with DynamoDB Accelerator. DynamoDB Accelerator is a caching service that helps to improve the performance of read-intensive applications that use the Amazon DynamoDB as a backend database by reducing the response time. Some of the key features of DynamoDB database includes automatic scaling. DynamoDB automatically scale the tables up and down based on the volume of request. So you don't have to worry about provisioning or deprovisioning the capacity. Low latency. DynamoDB is designed to provide low latency performance even at scale. High availability. DynamoDB automatically replicate the data across multiple servers to ensure the data is always available when needed. Global tables. DynamoDB allow you to create the global tables that replicate the data across multiple regions for high availability and low latency performance. Streams. DynamoDB streams allow you to capture and process the changes to the data in the real time. Secondary indexes. DynamoDB support the creation of secondary indexes to allow for efficient querying of data in addition to the primary key. DynamoDB is a great choice for use cases such as web and mobile application, gaming, and IoT. It is also a great fit for use cases requiring a high throughput and low latency data access, as well as for use cases that require a flexible data model. DynamoDB may be a bit expensive compared to other NoSQL databases, especially for high write loads. Additionally, it has a limited set of data types and does not support complex data structures like nested arrays or objects. It also has a relatively small maximum item size of 400 KB, which can limit the amount of data that can be stored in a single item. Finally, DynamoDB does not provide built-in support for full text search or graph traversal, which can make it difficult to perform certain types of queries. So next, we have two other managed services that you can leverage on AWS, and those are Amazon Elasticache and Amazon Redshift. Amazon Elasticache is a web service that makes it easy to deploy, operate, and scale an in-memory cache in the cloud. It is fully managed in-memory data store, meaning it can automatically handle tasks such as software patching, setup, configuration, and backup. Elasticache support to open source in-memory caching engines, Memcache and Redis. Both engines can be used to significantly improve the performance of web applications by allowing them to retrieve data from a fast in-memory store rather than relying on slower disk-based databases. Elasticache can be used to cache the data from databases, web services, and other sources, and can be easily integrated with other AWS services such as RDS, DynamoDB, and S3. It provides extremely low latency in terms of response time, and you can include things like scaling and read replica to meet your application's demand. And again, you can do this without having to be able to manage that underlying infrastructure. It handles most common use cases, including things like database layer caching. So if you are working with another database, even something like DynamoDB, and you want to add a cache layer in between your application and the database, Elasticache could help fill that need, and even session storage. So if you are working with a web application that is doing session storage, you can utilize the Elasticache with something like Redis to be able to get quick response or session data. Practical use case of Amazon Elasticache would be to cache the frequently accessed data from a relational database, such as product catalog or user profile information. By using Elasticache, the application can reduce the number of read operations on the database and increase the performance of the application. Next, let's talk about Redshift. Amazon Redshift is a data warehouse service. Data warehouse is a large centralized repository of data that is used to support the business intelligence activities, such as reporting, analysis, and decision making. It is designed to handle large volume of data from various sources and organize it in a way that it is optimized for querying and analysis. Redshift is a fast, fully managed, petabyte scale data warehouse service that makes it simple and cost effective to analyze all of your data using your existing business intelligence tools. It provides a massively parallel processing architecture that enables you to scale compute and storage independently for flexible pricing options and to accommodate the changing workloads. Redshift supports data loading from various sources, including S3, DynamoDB, and Amazon RDS. It also integrates with other AWS services like Amazon EMR and Amazon QuickSight for data processing and visualization. It is a cost-effective service that allows you to pay only for amount of data stored and the number of compute nodes used. And you can start with a smaller cluster and scale up as needed. There are various key functions of Amazon Redshift. Columnar storage. Redshift uses the columnar storage, which store data in a highly compressed and optimized format to improve the query performance and reduce the storage cost. Automatic compression. Redshift automatically compresses the data based on the column data type and the encoding scheme, reducing the amount of storage needed and improving the query performance. Data encryption. Redshift provides end-to-end data encryption, including data at rest and in transit. Workload management. Redshift provides the workload management features such as query the queues and concurrency scaling to manage the large and complex workload and improve the performance. Data partitioning. Redshift automatically partitions the data based on the sort case, which improves the query performance by reducing the amount of data scanned. Backup and recovery. Redshift provides automated backup and point in time recovery to protect against data loss and corruption.